Quirks, and you all came here to see Bob McDonald.
At least you know what I look like now, right?
Well, good afternoon, everyone, and thank you so much for coming. When Jim told me that we were going to be recording this show at 1:30 on a Tuesday afternoon, I said, who's going to show up for that? Thank you for proving me wrong. Thank you for coming today. You have any depressed Raptors fans here? I'm downtown, and I actually went into that crowd last night just to see what it was like. It was really so electric. We're ahead! Ah! Oh, we lost. And it was so Canadian, everybody just went home. There were no fights, no brawls, all right? They just went home. It's so Canadian. So as Jim said, this is this week's show. It'll be on this Saturday. People often say, how far ahead do you work on Quirks and Quarks? Every week. You do each show each week, that's it. So this is this week's show, which means you are part of it. You're part of the show. So these microphones can hear you. So that means if you hear something even remotely funny, die laughing. Just die laughing. Let me give you an example. Okay, so a scientist, a politician, and a journalist were out fishing. And a frog stuck its head out of the water and looked at the scientist, and the frog said, I have a PhD, I could be your thesis advisor. And the scientist said, I don't need a thesis advisor. So then the frog looked at the politician and said, I have a PhD, I could be your science advisor. And the politician said, I'm not interested in science. The journalist reached down, grabbed the frog, picked it up, and put it in his pocket. And the scientist said, why do you need a PhD? The journalist said, I don't. But a talking frog is a big story. Good. So just give us a second here to get going. And the other thing, I just want to rehearse the opening because there's a point where we're going to need your applause just in the opening before we actually begin during the show. And it will come right after. So I'm going to say hi to Bob McDonald. Welcome to a special edition of Quirks and Quarks, our first ever public debate recorded live on stage at the Isabel Bader Theatre at the University of Toronto and live stream on Facebook and YouTube at cbc.ca/Quirks. Okay, so just give us a second here to get things set up. Jim never lets me go. I can't do anything with that. Okay, so just give me a second to get this on. This is so Jim can talk to me. A little trick we play. And out come a distinguished. Going to introduce them one at a time, but we'll do that. Okay, let me just make sure that everything's all hooked up here. All right, Jim, can you talk to me? Gotcha. Okay. Ha! Are you ready? Ready to make some radio? Okay, let's give it a shot. Are we rolling and recording? That's a big important thing. Are we recording? We are. We are recording. Oh, the tension's mounting. Welcome, everyone, and thank you for coming today. We're going to begin the program in just a minute, but first we wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it's been the traditional land of the Huron-Wendat, the Seneca, and most recently, the Mississaugas of the Credit River. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. So now, on with the show. Hi, I'm Bob McDonald, and welcome to a special edition of Quirks and Quarks. It's our first ever public debate recorded live on stage at the Isabel Bader Theatre at the University of Toronto. And we are live stream on Facebook and YouTube at cbc.ca/quirks. And the question, the issue today is, should we have humans in space? In 1961, Yuri Gagarin became the first human in space. A short 8 years later, Apollo astronauts Buzz Aldrin and Neil Armstrong walked on the moon. We'll be celebrating the 50th anniversary of that feat in July. Since then, more than 500 humans have visited space, and some have spent as long as a year up there. In the next couple of decades, humans will return to the moon, could visit an asteroid, and perhaps even walk on Mars. We could one day, not too far off, become an interplanetary species. On the other hand, in 1957, 4 years before Gagarin flew, Sputnik orbited the Earth, inaugurating the space age. Since then, robotic spacecraft have visited every planet in the solar system, including places humans cannot go, such as the searing, acidic surface of Venus, or into the poisonous clouds of giant Jupiter. We've threaded the rings of Saturn, we've driven a small fleet of rovers on Mars, rendezvoused with comets, touched down on asteroids, even ventured into interstellar space. And we put powerful astronomical telescopes in space that have revealed the secrets of the distant and the ancient universe. So, these are the two paths we've taken so far. And our question for today is, what path will we take in the future? At the dawn of what could be a new era of space exploration, we're asking, do we need humans in space? And to help us explore this question, I'm joined by an illustrious panel of debaters. To start, someone who doesn't need much of an introduction. Chris Hadfield is, of course, one of those 500-plus humans who've flown in space. He did it 3 times. And on his last mission, he spent 5 months as commander of the International Space Station. Please welcome Chris Hadfield. Hello.
Thanks, Bob.
Now, Marianne Mader hasn't flown in space, but she wanted to. She's a planetary scientist who studied some of the oldest rocks on Earth in Greenland. She's collected meteorites in Antarctica, and she's worked on simulated lunar and planetary exploration missions. Please welcome Marianne Mader. And our next guest is on home turf here at the University of Toronto. Renée Hlozek is cosmologist at the Dunlap Institute for Astronomy and Astrophysics here at the University of Toronto. She studies, little things like the structure and fate of the entire... She studies little things, like the structure and fate of the entire universe. Please welcome Renée Hlozek. And our final guest is someone whose voice has become familiar to Quirks listeners this year on our run-up to the anniversary of the moon landing. Amy Shira Teitel is a spaceflight historian, writer, blogger, and runs the YouTube channel Vintage Space. Please welcome Amy Shira Teitel. Now, first, just a little business for our audience online today. After our debate, we're going to have a little time to take some questions from our panelists. So if you find yourself with a question you'd like to ask, you can send them to us on Facebook, YouTube, or tweet us at CBC Quirks. Now, since we're dealing with such a huge question today, we're going to break up the show into several little mini debates. And the other big thing I should point out is that our debaters today are not always going to be arguing the position that they may favor, and you'll see how that works out as we progress. So first, our first mini debate is this. Resolved. The space race and the Apollo moon missions proved, yes, we should have humans in space. Arguing for this resolution, we have Chris Hadfield and Marianne Mader. Arguing against it will be Renée Hlozek and Amy Shira Teitel. Now, we're going to give our teams of debaters here just a little time to organize their arguments. So, debaters, you have 30 seconds to discuss what you want to say. 30 seconds. Do you know Alex Trebek is a Canadian? Coming up. Everybody looks fine. Okay. Your time is up. I love doing that. The Soviet and American rivalry took us into space. We had Gagarin as the first man in space, the rival Mercury 7, and then the race to the moon. Did this prove we belong in space? Chris and Marianne, would you like to start?
Sure. Thanks, Bob. And thanks, everybody, for coming and talking to everybody online. Let's see. On June 2nd, 1966, Surveyor 1 landed on the moon. An unmanned, a robot vehicle landed on the moon. It just had its anniversary. Did anybody celebrate? It was a significant achievement. It was a necessary precursor in order to try and improve the technology after many, many failures, because trying to do things robotically is a lower cost but also a higher risk. And yet, just a couple years after that, on July 20th, 1969, when Mike let them undock and then Neil and Buzz stepped down onto the surface, there were more people tied in watching that than any other television event in history. It engrossed people all around the world. In advance, people were fascinated about it. It became an important part of human culture. Real time, an unbelievable impact on people all around the world, including this little Canadian kid. And in the 10 years after Apollo, there were more PhDs, technical PhDs in the US per capita than at any time prior and any time since. It changed people's ideas of who they could be based on the example of those people exploring space. So Surveyor was great. Sputnik was great. But what really inspires and challenges people in order to be more competent contributing members of society is the actions of other people. And when it's something as challenging as trying to land on the moon or elsewhere, to me, it's absolutely necessary that people are involved.
Okay, so the astronauts get better press than the robots.
That's what I was going to say, yeah.
Marianne.
Do I get to go next?
Yeah.
Oh, fantastic. I thought I was going to listen to them. So I think it's more than better press. I want to pick up on something Chris said about culture. I think Apollo grew a science culture, and not just in the US. This is something that spread across North America. It spread across the world. So, I mean, what is science culture? We're talking about people really valuing and appreciating science and how we do science, okay? They valued we have a knowledge-based economy or a society. That is huge. And in talking about it going outside of the US, I have actually a really good friend, Tanya Harrison, and she's writing a book on Apollo, gathering stories from people around the world about how it influenced them. And these are people who were not in the US, they were not in the then Soviet Union, and the stories are all similar, that they weren't aware or paying attention to a space race or politics. They were aware that humans had done something sensational. And that is what stuck with them. So this idea that the Apollo united the world is not insignificant.
Okay. And speaking of international, Canada was part of the Apollo 11 mission to the moon, by the way. You may not know this. But the foot pads on the lunar lander were made in Montreal. So we can say Canada was first to set foot on the moon. Okay, Renée and Amy, how about the other side? We don't need humans in space. Robots are the way to go.
Well, so I think space is great. I just want to say for the record, I'm heavily invested in space with my whole career and my whole life. Really what Apollo showed us is that humans are incredibly competitive and that political agendas can drive funding for science. As exciting as that was, why was there so much money in space at the time? It was there because of the Cold War. And so I think we need to look at things in context. We have made incredible advances in robotics. I know we're going to talk about that a little bit more later. But the reason why Apollo was so successful is because it was part of an agenda to show dominance. And that's also why there was so much money for PhDs. I don't think that necessarily we can't get the same incredible exploration without humans in space.
Yeah, to piggyback on your point that it was the Cold War, I once had a little girl in Hobart, Tasmania, ask me, why did they go to the moon with humans and not robots? And I just thought, how do you explain pissing contests to an 8-year-old in a country where they don't study the American-Soviet Cold War? So yeah, I think we have this like really big problem of romanticizing Apollo, and I say this as an Apollo historian, just putting that out there. We have this idea of romanticizing it, and if we're talking about science and kind of the role that humans have in space, only one scientist went to the moon on Apollo. Jack Schmitt, the lunar module pilot of Apollo 17, was a geologist. Everyone else was a pilot. We know pilots make amazing astronauts. They are not necessarily scientists. The Apollo 12 crew had cheat sheets on their wrists of like geology terms to throw in to like please the guys on the ground listening so they would feel like they'd learned something. We got more data and more science out of the scientists actually looking at the rocks that were brought back. We've gotten more science out of the robotic missions that have landed on the moon before. We learned so much from the Surveyor program that we couldn't have done Apollo without it. So much more came in this like straight science from the robotic stuff that happened out of Apollo. We're still using Apollo era data because funding levels have just like plummeted since the 1960s. We're still using that data. That is the hard stuff, and it's all the stuff landing on Mars. We're still using the science, and it doesn't have to do with the human element.
All right.
Sorry, astronauts.
It's also dangerous putting people in space and expensive to put people in space.
I mean,
Anyway.
everything in space is trying to kill you. Do you want to speak to that?
Just like Australia.
So mix it up. You have a minute here to mix it up.
So I would rather have pilots on the moon checking their notes about geology than geologists in the cockpit checking their notes about how to fly.
Okay, very fair point.
I just wanted to bring up an earlier point. I understand that everyone was watching TV, but have you seen the Curiosity rover Twitter feed? Like, that's gold. Robots can do PR really well, too.
There's a chance that's people writing that.
What?
Okay, well that was that was our first mini debate about humans in space. Time to get on to our next mini debate. Resolve: the golden era of robotic exploration from the 1970s until now has proven we don't need humans in space. Now, before we get to this debate, as we were organizing this event, Chris was our first guest to confirm here. And one of the things that was pointed out to us is that it's kind of hard for other people to participate, convincing them to debate against Chris. You know, how do you do that? In fact, Renée, I think it was your colleague, was it Professor Roberta Abraham, who actually said, "Are you crazy to do that?" So, to solve this problem, we're going to make Chris Hadfield do it. Okay? So we're going to change up our debate team. So, Chris, you'll be arguing against humans in space, pro-robotics.
Okay.
So, Chris and Amy, can you change places, please? Sure. Okay? All right. So, again, the topic for this debate is the golden era of robotic exploration from the 1970s until now. It's proven that we don't need humans in space. And again, we're going to give our debaters just another 30 seconds to decide what they're going to do.
I hate people in space. Oh, they heard that.
So René Descartes, the philosopher who said, "I think, therefore I am," he walked into a bar. The bartender said, "Would you like a drink?" He said, "I think not." Then he vanished. Okay, time is running out. 30 seconds are up.
Okay.
Do we get extra points because they took longer?
No. So back in the 1960s, we started to explore the planets. It started with the Soviets and their Venera and Zond missions to Venus and Mars, Americans with their Mariner missions. Then in the 1970s, we started to go farther and farther. By the time New Horizons flew by Pluto in 2015, we visited every planet on the list. Robot exploration has reaped enormous scientific rewards. So does this show we don't need humans in space? So Renée and Chris, would you like to kick this off?
Sure. So we have put people in space, that's fantastic, but we've made incredible advances in robotic technology. And one of the biggest results of that is that it is much, much cheaper to put robots in space than humans. So the Mars rover missions cost around $2.5 billion US. Projected costs for a future human trip to Mars is in excess of $300 billion US. The costs are, and that's after we develop a lot of technologies. It just doesn't make sense financially to put humans in space any longer.
Orbiting the world right now are hundreds and hundreds of robot satellites, none of them with people on board, that are providing all sorts of absolutely necessary functions for society, giving us our weather, giving us navigation with GPS, giving us telecommunications, allowing us to talk to everybody across this country and around the world in this broadcast. And further out in the solar system, as Bob said in the intro, we have gone all the way from orbiting around Mercury all the way out to orbiting or flying by every single planet and asteroids and comets. What we know about the origins of the solar system, that comes from robots, not from people. And Star Trek would seem to counter all of that. But let me just do a little math here. I don't know if y'all remember, but when Kirk was just taking it easy, they'd go like warp 1. Warp 1 is the speed of light. Warp 2 is 2 cubed the speed of light. So 2 times 2 times 2, so 8 times the speed of light. When he was like putting it like to the normal speed limit, it was like warp 5. So what's that, 125? But when he was really angry with Scotty, he would take it all the way up to warp 9, which is 981, 729. 729 times the speed of light. If we wanted to explore our own galaxy, it would take 250 years at warp 9 just to get from one side of our galaxy to the other. They were on a 5-year mission. They never left the neighborhood. So the only way we're going to be able to explore is robotically. It's not feasible for people to be able to explore anywhere except right here next to home for things that are extremely simple.
And who could forget the Hubble Space Telescope that took us even further out to the edge of the universe, robotic telescopes. All right. Amy and Marianne.
Go ahead. Okay, so let's bring it back to home. So we obviously need robots and satellites. When we do field geology, we start with scouts. We start with surveys. And that's what these guys are. These orbiter satellites around Earth and other planets, they are the first wave of what you need to do the actual science. When we do field geology, we look at satellite images, and then you start doing a survey. Rovers are pretty good for surveys, that's pretty decent. But if you want to understand the geological history of a place, you need boots on the ground. I mean, that's probably realistic for the Moon and Mars. I'm going to constrain my answer to those places because I think we do need people there to understand the geological history of those places. So I really appreciate that Renée brought up the Mars exploration rovers and how cheap they were. But they also took like 9 to 15 years to do what an astronaut could do in, say, a month, okay? So humans are way more effective of doing that kind of work. So you're like, oh, whatever, who cares? Let's just take all the time we need to explore. I would still argue that people are better because we have better situational awareness than these robotic assets on other planets. So when you're a field geologist, you look at multiple scales, close up, far away, you're taking different data sets, you're integrating it on the fly, you're adaptive, you make guesses, you solve that. That's how you do field geology. Those rovers aren't able to do it. And I even thought of like a counter argument because in my head, I'm one of these like, oh, VR, it's so cool. And I can imagine someone being like, hey, what if we just get better images of Mars and we make a VR cave on Earth and the astronauts explore in the VR cave? We don't need to send them. Well,
Great idea.
Great idea, right? I mean, you can only create a VR experience on what you see. So it's on what the cameras can see. Right now, that is not enough to make an immersive experience. So then you're like, okay, well, we need more rovers. So let's send a suite of rovers to get all these different images at different scales. And oh, let's throw in some drones, because you can maybe do that on Mars. And we'll get some more images. And then we'll have all of this data, and we'll send it back to Earth. Oh, but then you need a new communication system, right? Because right now you send, what, I don't know, like 2 to 5 minutes worth of a Netflix show uploaded a day to Earth. So you're going to need a whole new communication system to get all that data back so you can have your VR cave. So when we're starting to talk about expenses and doing really effective field geology to understand the geological history of our inner solar system, humans are better.
Oh, okay, so good.
I like the VR element.
Robots aren't so cheap after all, Amy.
So there's one other thing that you sort of touched on a little bit with the VR thing, which is the light time delay. So Chris brought up light speed. Let's talk about light time. So light takes time to go between distances. The average light time, one-way communication to Mars, is 7 minutes. So let's say we have Curiosity taking a picture of something. Well, Curiosity is pretty smart. It's got like basic hazard avoidance and stuff, but it doesn't know if a rock is cool. Now, you're a field geologist.
Yeah.
How long does it take you to look at a rock and say, and look at another one and say, I want that, I want to crack that open, I want to do chemistry magic, I don't know rocks, but I want to do chemistry magic on it. Whatever you do, I mean, less than 7 minutes?
Definitely. And you know, too, you're keeping a catalog in your head of if you want to return to a place or not.
Right.
Right?
Curiosity can't do that. Curiosity takes a bunch of pictures and it sends them back. So that's a 14-minute light time delay of like, take a picture, take the picture, send the picture back. Then the scientist has to like look at it and analyze it and decide, do we do more here? Let's do that. Let's send the command up. And I think they only have like 1 or 2 windows per day to actually send commands up to the rover. And it's also like drive commands, every command. So it's like, if you get your bit, if your science team has a bit to add up to the rover, then you get to add your task and you might not get all your tasks down. That's a huge problem. The data management is a huge problem. And so let's just argue that like we can't put, it's easier with the robots on Mars, fine. But what about like the hybrid of having robots on the planet, having rovers on the planet, and having humans in orbit around Mars? And then you take out the light time delay. All of a sudden, at least like if you're not there to touch it and your boots on the ground, at least you've got the brain catalog and all of that fast stuff happening in a way that's way more. You're going to get so much more bang for your buck. And we all know space is really expensive. You're gonna get more.
Okay.
Do it. Humans.
We're down to a cost of economics here. Mix it up. What do you think?
So good points. I love a worthy opponent. Good points. When the shuttle was originally designed, the reason the shuttle was the shape it was for the best of optics technology, and we wanted to put up spy satellites. We wanted to launch out of Vandenberg, California, go straight north, go halfway around the world, take pictures of what at the time was all the hot spots on the other side of the world, and then come around and land after one orbit. That's why the shuttle has wings, and it's why the shuttle's payload bay was sized, because the size of a good enough telescope in the late 60s would fill the entire payload bay, 60 feet long and 15 feet across. By the time they could get the shuttle even properly to the drawing board, the technology had gotten better to make that obsolete. And we never did do that. We never even flew the shuttle out of Vandenberg. And the arguments that you've put forward have not anticipated the fact that the pace of invention is accelerating. And if we can take our ability to be a thinking geologist with the huge amount of information that you have accumulated so far in your life and use that as decisional within some sort of artificial intelligence that is learned through machinery, that's actually the best way to explore, because we can take the whole sum of human knowledge and send it out in very small packets that will never die and go infinitely, and we won't lose all the things that we've invented here on Earth. So to me, anticipate the fact that our inventions are going to continue to get smaller and smarter and better, and that is where the future of exploration lies.
So to continue your Star Trek analogy, instead of sending the whole Starship Enterprise, just send data.
That's
on his own.
Just or one USB stick.
He doesn't even need a spaceship.
So even if that is the case, which I believe is, things will eventually get smaller and more compact and better able to do it. Contrary to that one crazy Uber driver I had once, robots aren't going to invent themselves better. Humans are going to do it. We're going to need the field geologist telling the robot what to look for. So when that AI is going to come from a human. There's always going to be that human element. And even now, I mean, you look at data. You look at data coming down, and it's the human that's interpreting it. It's the human who, spends a lifetime studying a planet. I worked with the New Horizons team, and I saw the science team breaking down in tears because the data worked.
But the key thing is
human there.
They're doing that on Earth, right? So you can do the training for something like a machine learning algorithm on Earth. The difference is we are getting better at predicting decisions. We're not actually getting that much better at keeping humans safe in space. So there are places that you can send a rover once you've trained its brain with fantastic geologists, but then you can take it to parts of the of planets or the solar system that really we haven't gotten great at protecting humans, and that we're not going to be able to do that rapidly enough, right? Robots can do things that humans can't, and we can train them on Earth.
Robots are also a lot more patient. It took 9 years to get to Pluto. That's a long trip to live in a tin can.
I have a quick add-on to this because I was thinking that initially my answer would be AI is going to take the role of the geologist. And so I called a friend who's an AI specialist.
You phoned a friend?
I phoned a friend.
All right.
I wish we could do that now. Dr. Raymond Francis, he's from Sudbury. He works for NASA JPL. And he's the one who is deploying autonomous software on Curiosity rover so that it can zap some rocks when the humans are sleeping. Okay, so he's designing this software. And I was like, okay, if anyone's going to know if we can create a future AI rover to replace us as humans, it's going to be Raymond. And he didn't think so. He was saying that humans, we are generalized intelligence. So what I was talking about,
everybody asks Raymond,
and intuition, and we have that. Whereas these specialized AI-based robots or software, they're really good at specific tasks. They're really good at being like, there's a dark rock, there's something that looks different. But that integration of scale, close up, far away, different kinds of data sets, that intuition, it's not clear that's going to happen.
Artificial intelligence are already better at reading X-rays than people are.
Yeah, but X-ray is one data set. That's a very specific task.
Yeah, but it's
right?
the game's just
We
different.
talk about structural geology, geochemistry, field geology, making hypotheses, testing. Anyway,
what's going
I
to
don't
happen?
want to be. I'm happy for this debate because I'm curious. I'm curious if that's going to be possible because that's a level of intelligence in AI that we certainly do not see now in anything that's capable.
But they're getting smarter.
Yeah.
They're getting smarter all the time.
then
Well, it sounds like our debate is getting pretty close here. Humans versus robots. That's the end of our second mini debate. You're listening to a special edition of Quirks and Quarks. We're hosting a live public debate at the Isabel Bader Theatre at the University of Toronto. And we're live streamed on Facebook, YouTube, and CBC Quirks. Our topic, should we have humans in space? Our guests today are astronaut Chris Hadfield, cosmologist Renée Hlozek, planetary scientist Marianne Mader, and spaceflight historian Amy Shira Teitel. And just a reminder for our online audience, after our debate today, we're going to have a little time to take some questions for our panelists. If you find yourself with a question you'd like to ask, you can send them to us on Facebook, YouTube, or tweet us at CBC Quirks. Okay, on to our next debate, and here's our topic. Resolved. With new launchers and a developing private space industry, we're on the cusp of a new and welcome era of humans in space. So once again, we're going to switch up our teams here. Arguing for humans in space will be Chris and Marianne, and arguing against it will be Renée and Amy. So Chris and Amy, if you don't mind switching again. And once again, our panelists have 30 seconds to prepare their brains. Do you like my shirt? It's got constellations in it. You can see Orion over here and Big Dipper. Here comes the moon. Oh, no. Just kidding. Just kidding. Sorry. Okay. That's not going to make it to air. Okay, and our 30 seconds, thankfully, are almost up. All right, okay. Okay, good. Okay, so we have super rich entrepreneurs like Elon Musk and Jeff Bezos with ambitious and innovative plans for space launches and exploration. Virgin Galactic hopes to be flying suborbital space tourism flights this year. Is this hype, or is this a new era for humans in space? Let's start with the con side this time. Renée and Amy, let's tell us why you don't think the entrepreneurs are going to take us to space.
So there are a couple of things I think we need to get clear at the beginning. The first is that while a lot of private industry invests in space, a lot of them are doing that because of public tax breaks and public funding. There's an incredible amount of money that comes from public agencies that funds private companies, so it's not completely a separate divide. But if we take that for a second, I have a big concern because if you're a private company, you are motivated by profit, you are not necessarily motivated by science, and you're not necessarily motivated by ensuring the best humanity for all people, which is typically what we're told space will give us. And so I think it's a red herring to just assume because someone has an innovative solution, great, that we should give them free rein to build a company that is motivated by profit and not by scientific endeavor.
Yeah, I think the competition between the private companies is also great. But like you mentioned, there's SpaceX, there's Blue Origin, there's Virgin Galactic. Okay, so we saw already in the first debate that competition with the Soviet Union and the United States brought this amazing revolution of technology and sort of early spacefaring technology in the 60s. In America now, we have basically 4 entities duplicating each other in an attempt to out-big each other. It would be really nice to say, well, here, Elon, you're really good with the Falcon Heavy. Let's give you low Earth orbit. And then, Branson, you're doing the suborbital stuff for all that stuff. And maybe let's pool together for the deep space heavy launch vehicles that need to go to other planets and to distant goals. There's a lot of duplication, and a lot of it, I don't even know how the regulation is working of like, it's all launching out of NASA sites right now, except I think Richard Branson is not, but he's suborbital, and I don't know if that's a different regulation or not, but there's a lot of duplication, and I feel like we would go further together. I feel like that's someone's corporate logo, and I don't remember whose. Further together?
Okay, so going for profit is not the way to go, as opposed to going for science. Okay. Chris and Marianne?
Want me to go first?
The privates.
I don't know why it won't work in space when it's worked in every other industry. Initially, someone has a crazy idea. It's not commercially viable. It takes a bunch of research. Someone has to put a bunch of money into it that doesn't get anywhere, like aviation. NACA, the predecessor to NASA, spent a fortune building the huge wind tunnels that still exist in a lot of places across the United States, pushing the edge of the technology, developing the technology, so that eventually we can effortlessly now ride in the fruit of all that and travel the entire world in great safety and comfort. If we could get to space for the price of getting to Regina, people would choose space, I think, more often.
I hope this isn't airing in Regina.
Nothing against Regina. That's where my family first settled when they came to Canada, and actually in Moose Jaw, just a little down the road. But the real question is, can we make it inexpensive enough that it becomes just another means of transportation? We were forbidden from sailing out of sight of land for entire 300,000 years of human history up until just very recently, 500-600 years ago, when our technology got good enough. And all of those technologies have advanced, and that's allowed us access. And competition is good. That's why we have the Olympics. Imagine if they just said, Russia, you're good at the hammer throw. No, we're not going to have a competition. Just throw the hammer, and we'll all watch you. And that, it would not be a very good Olympics, and we would never break the records. We need competition in order to thrive and really push the limits of things. And I think Elon has dropped the cost of getting to orbit within the last few years by almost an order of magnitude. He's moved the decimal place one over, and it's continuing to move. And he went from nothing to owning the world's launch market in a decade. And that didn't happen accidentally. That happened through his perseverance and competition. And I think it's opened a lot of doors. And I think the more people can see the world the way that I've seen it, to go around the whole thing, to start thinking of the planet as one place and not as my little square of it, and to think of the rest as sort of imaginary and unimportant, I think it'll be a healthy thing for us all. So I'm happy that we're doing it.
Okay. I can see a future where spaceships will have logos on the outside like race cars do. You know, all the sponsors will be on the outside. It'll be like that.
Sure.
Marianne?
Yeah, it's interesting. We are on this cusp of an era. So we're at the beginning of it, where we're starting to see launch costs drop. What will that look like in another 10 or 20 years? So with that cost barrier coming down, more people will have access to space. That's an interesting concept. I'm actually going to take another tact about entrepreneurship within the space industry, and who does that attract to our industry? And so we're seeing this new wave, I would say, of aerospace engineers, of scientists who have grown up in a connected world. They want to make a difference, they want to make an impact, and we're seeing them converge in this kind of new industry of new space. And I think that's really exciting, because I think we're starting to see diverse ideas. And once you have diversity within industry, that's where you're starting to see innovation. And so I'm actually really inspired by an aerospace engineer here in Toronto at MDA, Natalie Pennick. And she lives of a philosophy. She's an outdoor explorer, kind of mountaineer, hiker. And that concept of leave no trace. That's something very familiar to hikers. You know, you don't leave pollution or junk around. You take everything in, you take everything out. And she's one of those people, she wants to apply this to this industry, into new space. When these kinds of philosophies are going to be incorporated into the work, I think we're in the cusp of a new era of space exploration and how we're going to do it.
Meanwhile, we'll be mining the asteroids, and we'll have tourists running around the Apollo 11 site saying, "Oh, look at that, taking stepping on the footprints." Yeah, I'm really excited about the space tourism part of it, because then maybe I get a chance to finally get up there. Anyway.
So I'm going to chew the microphone off. I'm super excited. Thank you for giving me the return volley. You talk about leave no trace. So typically in some of the Falcon heavy launches, they shut down airspace for 2.5 hours for a 10-minute launch window. And I looked it up online when I was preparing, that apparently in one of the recent launches, the planes had to take detours, adding 35,000 nautical miles to their journeys. If we care about the planet and protecting the one that we live in, we're just adding needless cost until we actually figure out what we're doing. And I don't think that allowing a couple of innovative entrepreneurs, as great as they may be, to dominate a space industry and just send off rockets all the time until we've actually figured this out is the way to go. And I worry that we'll do exactly the opposite, that we just want to leave Earth because we didn't do a good job and we think we'll do a better job round 2.
Okay. All right. So here is our last mini debate for today. Resolved. It's a question of the future. Practically and morally, the future of humanity is in space. And once again, we're going to switch up the teams. Chris and Amy will be arguing that the future is for humanity. It is in space, and Marianne and Renée will be arguing that it is not. So Amy and Marianne, you switch places here. And once again, we have 30 seconds. Is the future of humanity in space? Do you know that there are 3 kinds of mathematicians? Those who can count and those who can't. Or you can say there are 10 types of mathematicians, those who know binary and those who don't. That's for the geeks.
You're killing it with the science dad jokes today.
Science dad. Oh, you are one.
Okay, and our 30 seconds are up. So there are nearly 7 billion of us on this big blue marble right now, and we've explored and inhabited nearly every corner of it. Will we? Should we push beyond our planet? And once again, we're starting with those arguing against the idea of humanity's destiny in space. Marianne and Renée, take it away.
Yeah, so everything I said before, you can just ignore that. Actually, I am going to frame this. So I think it's important that we do have humans to do exploration. So what I was talking about before, field geology. I do not think we need humans to go out and live in permanent settlements in space. So I think there's a distinction there, and I'm just going to make that distinction and kind of for the case of my argument. So for long-term settlement, humans, we're a species that we're designed to live on Earth. We have 1G, we have breathable air. This is what's healthy for us. I don't think it's ethical or moral to send people off to live in these environments where they can't live. Mars is really hard to live. We don't have people permanently settled around hydrothermal vents in the ocean, on the top of Everest, or even Antarctica. Okay, we have research stations and bases, so these temporary places where people go, but we're not permanently settled there. It doesn't make sense to permanently settle on these other planets. I'm sure there's some folks out there who are like, oh, but we have to. We're going to destroy ourselves, and we've got to go someplace out, and we'll just terraform Mars. If we can terraform Mars, which is a technological wonder, I'm pretty sure we can solve our problems here on Earth,
So I agree with everything you said, my fantastic panelist colleague. But I also think there's another, even more subtle issue that we need to think about. A lot, as we talk about space exploration and settlement, I agree with you, there are two different notions of being in space and living in space. A lot of the debate and discussion uses language that talks about colonizing space, that we should go out because we can, because we should, and basically make space our own and take over Mars. That's a very dangerous narrative that has been very troubling on Earth. And if I think about that, if we think of who is defining that conversation, leaving no thought to the second we put our foot on Mars, that kills. If you wanted to understand if there's life on Mars, that's it, you contaminated it, right? Also, we don't know about how best to protect the planet. Some people think about this, and there are people that, how to protect the solar system. People are focusing on interplanetary ethics, but we have a long way to go before we even understand how to frame that argument. And my real fear is that we're going for technological advancement and excitement without thinking of the genuinely troubling ethical issues with colonizing the solar system at all.
So in other words, we could become an invasive species to the Martians. Exactly. We could be. Okay. Chris and Amy.
So in the same way that you mentioned we've evolved on Earth with 1G, with the atmospheric pressure, it's possible that maybe we need to evolve to other planets for the sake of preserving humans as a species. And it's obviously not going to happen overnight unless there's like a freak mutation storm or something. But over the years and over the generations, I think we owe it to ourselves to preserve our history beyond where we are. I mean, it's like if you imagined a pocket of humans learning everything in the space and no one else ever knows about it, and then they all die. What if everything we've done as a species, everything we've learned, all of our science disappears one day because X happens? To preserve ourselves, we need to start understanding the challenges of living somewhere else so that we can preserve our humanity for future generations who may be able to breathe carbon dioxide on Mars or may be able to float in the clouds of Venus. You never know. And then they'll be like, remember 2 millennia ago when all that stuff happened? Because, it could happen. We owe it to ourselves to keep that dream alive.
So the two arguments I heard from the other side were you should never leave home. And we've made mistakes in the past, so therefore we shouldn't do anything in the future. I don't think both of those are necessarily completely credible arguments. I understand the basis of them, but we can do better. And there's a difference between rampant, ignorant colonization and thoughtful settlement. And we've managed to do both in various places in human history. And I think the important part, especially for people that are in the space business, is to get involved in that whole conversation now. Because we've already been living in space for the last 19 years. We have essentially settled on board orbiting research station. And I spent 5 months up there, but there's 6 people, including a Canadian, who's going to land here on the 24th. So it's already happened, and I think it's a natural progression. As infants, we learn to walk, and this is by fundamental human design. We learn to walk far before we learn to talk. We have to go explore and see to try and understand things far before we let anybody else just explain them to us. It's basic to our nature. And so we're going to be involved in exploration. Humans, it's our absolute drive. And there's also the thought that there are far more resources away from the Earth than there are here on the Earth. We have a limited bubble that we all breathe in. If we can find resources on the moon, which is dead to any natural life, or specifically on asteroids, which are obviously dead to natural life, there's a tremendous opportunity, if we can get the cost of transportation down, to manufacture and process in a place that doesn't, by its very nature, pollute the place where we live. You don't have to do it in your own backyard. Right now we're limited by the cost of transportation. If we can continue to get that to drop, it gives us one more reason, I think, to have people permanently living off the Earth. I think it's the natural progression of what's happened for the last 300,000 years. We're just waiting for the technology to get good enough, and let's do it right.
On the other hand, we live in the Garden of Eden. We live in the Garden of Eden.
And how well did that go?
Of all of them.
Since you boiled our points into 2 pithy ones, you're just saying it's okay if you smash all your toys because I'll buy you new ones? That on the moon, right? I agree that we have other resources in the moon, but we want to make sure we don't even know how to look after them on Earth. Right? I worry that this idea that we just go somewhere else and it'll be okay because we'll figure out how to man an asteroid. My bias, of course, is I want to understand the universe. I don't need to necessarily go and live there. But I worry that we're telling ourselves it'll be fine because we'll do it better next time round when we can't even do it better this time round.
But maybe it kind of goes both ways, that while we start looking at other planets and other bodies to start setting up these little research stations that become permanent, we start to understand how to work with resources better, and then that trickles back down to Earth. So maybe one of the, we start exploring other places to live, we start colonizing, we start figuring out how to do it, although I agree, different word than colonizing. We start setting up these ports for humans to live, and we can then, at the same time, learn how to live better on Earth. The two things, I think, if we go elsewhere, we can actually do ourselves a lot of help here, too. And we can only do that by learning how to deal in adverse situations off the planet.
So I recently saw a quote, I think it was a science journalist who said, "We're only as good as our home planet." And so there's no reason to think that the societal issues that we face here on Earth won't follow us when we go and set up settlements elsewhere. But I actually agree with the last note that Chris said was, let's do it right. Is the things that are happening now is we're involving social scientists. We're involving ethicists. This is a part of our space industry now, which is a critical part that maybe when it first started wasn't there. So I'm optimistic that we can do it right, but we need to be cognizant and aware of the challenge. This is why I appreciate this kind of dialogue, because it's not straightforward.
I'm chair of the board of a little space company, and we are trying to develop the technology to get to the moon cheaper than we've ever gotten there before. But the fundamental reason I'm part of that company is because its real motivation is to try and influence the discussion on how we should become a multiplanetary species. What are the rules? I mean, you say we've messed it up on the Earth, but it's not uniform. The Earth isn't just one person and one set of decisions. And the settlement of Antarctica is wildly different than the settlement of other continents that we've sort of arrogantly stepped all over. And no matter when in history, it's just happened faster more recently. But Antarctica, we've adopted a different model for how we settled down there and how we live there and what the laws are. On the International Space Station, we do not live by any one country's laws. We live by the International Crew Code of Conduct. It's a different set of laws off the planet. That's a pretty nice precedent for what we're going to do when we go further. We need that precedent. If the worst thing that could happen would be 50 years from now, there's a little America and a little Russia and a little China on the moon, and we've just transplanted our problems to another place.
So just to pick up on that point, I agree that cooperation and dialogue is really the way forward, and that's why this is so fun. But a question that I have is, if we are also saying we should go for private industry, lots of innovation, individuality. How do we make those two things happen? Cooperation, not little countries, while still saying please all compete with each other.
I agree.
Okay, here's perhaps a compromise that would satisfy both sides. What if we did it like a hybrid? We create a robot that's sort of humanoid, and we download our minds into the robot and send the robot out there.
I mean, I'm okay with that. Yeah, I'm okay with that. I also should say, I care about the beginning of the universe and the end of the universe, so my research it doesn't matter how fast we go, even warp 9, I can't learn anything. I got to wait for the light to come from the Big Bang, which I'm fine with. But I do think that those kinds of practice runs, send the mini data, do a bunch of machine learning technology, figure out some of the questions would be ideal as a start, while we then come up with some of the laws for the data bots to interact with each other, right? We can simulate some of the interactions that humans would happen just with artificial intelligence.
I don't think we're going to stop humans from going to space. I agree with Chris. This is what I actually believe. Like, it's in us, right? I think the need for regulation is critical. And when we're talking about this new space era, and I guess maybe I'm hopeful that it takes a while to prove, sending humans into space, and I'm really hopeful that our regulations and our policy kind of catch up and do that work before it's just kind of a wild scene.
I had the privilege of speaking with Buzz Aldrin, who was on Apollo 11, and he said, the moon's a really interesting place, but it's not a very nice place. And he was right. The moon will kill you. There's no air. There's no water. There's
water.
Well, there's water at the South Pole. Sorry, Chris, yes. But you'll die if you go outside without a spacesuit on. Mars will kill you. So will Venus. So, in fact, every planet we know will kill you. And so if we're going to leave, it's going to be really, really hard. They're difficult environments. They're really, really far away. And yet we're leaving behind the jewel of the solar system. And I said, well, why are we doing that? What's going on?
Well, you don't have to leave it behind. You can do both. I mean, there are people that bungee jump. I mean, why would you bungee jump? I mean, it serves no purpose. It's a big risk. There's no reason at all but lots of people like bungee jumping. I mean, there's always going to be people that want to do something different than the other people. And so it's not just one homogenous group. And if you give people a challenge, there will always be people that try and rise to the height of the bar that you set. And I think the International Space Station is a terrific example of that. 50 nations of the world that do not get along have been cooperating 24 hours a day, 7 days a week since the early 90s to settle and explore the rest of the universe. And you can go outside all this week and look up. It's early in the morning. You can watch it go over. It's a really amazing thing that we've accomplished. We've done that thing in human spaceflight settlement. It's not perfect. It's not completely solved, but it's a pretty good first step.
Okay, so that was the end of our last mini debate. Now, we've heard from our guests. Okay, now we've heard our guests argue both sides of this debate, so I think it's only fair to give each of them a chance to summarize their favorite argument and whether or not they've been convinced and changed their mind during this debate about whether or not we should have humans in space. So let's start with our spaceflight historian, Amy Shira Teitel.
First, I feel like I have to say after that last one, I really feel like we need to protect our planet before we start colonizing others. Please, let's not ignore that data. It freaks me out a lot. But as for humans in space, I think it's inevitable. I mean, like we've all said at some point, it's this inevitable push that humans will be off the planet. I personally don't think it needs to be now. I think there's a lot more we have to understand. I don't know why there's this push on Mars when we still don't really know how humans are going to live and work on Mars, let alone survive the potentially 2-year-long journey and the radiation. And I don't think we need to rush it. I personally feel like let's give it a few decades and really understand the problem so that when we get there, we have the best chance of survival and we have the best chance of actually getting what we need out of the mission instead of doing it for the sake of doing it.
Thank you, Amy. And now on to our planetary scientist, Marianne Mader.
So I'm actually going to play off of that because I agree. Right now, we haven't done effective studies to understand how humans will be physiologically in 1/3 or 1/6 gravity. We still need to do that work. I think we will do that work, and I think we will send humans, obviously back to the moon and onto Mars for longer durations. I am curious around what the evolution of AI and machine learning will allow. I'm a huge proponent of robotic-human partnership in exploration strategies. I think that is the true reality of how we're going to explore certainly our inner solar system. So I think that's going to be in a very exciting area over the next 10 years, and I'll be following for sure.
Thank you very much, Marianne. Next, our cosmologist, Renée Hlozek.
I think the human mind is incredible, and we are driven to understand the universe. I've devoted my life to try and understand what the universe is made of and how it's changing, and I know that our need to figure this out and to be in the solar system will continue. I want to make sure that we understand what we're doing and that we give the solar system and our planet the kind of respect it deserves, and that we give each other the respect that we deserve as we build a new vision potentially for the future. Because I want to make sure that it's a solar system we can all still live in, that isn't driven by only those that can afford the ticket or that have the political savvy to get into space.
Thank you, Renée. And finally, our astronaut, Chris Hadfield.
You don't have to be a very good student of history to know that things ebb and flow. And there are moments when things come together where something comes possible for political reasons or technological reasons or just the way things go. And if you don't take advantage of that moment, it may not come around again for a long time. And so that does add a sense of urgency to where we are right now. We've had an extremely long period of peace. We've had a tremendous period of growth. The quality of life for more human beings is better now than it's ever been in history. The strides we've made in the last 25 years are unprecedented and unbelievable. This is a really good moment to try and push ourselves and see where our limits can take us. We have to do it ethically. We can't, the arguments that we're going to abandon Earth, that's not the motivation to explore. The motivation to explore is understand we can't even properly measure our Earth unless we go to space. To be able to get a data point around the entire world every 90 minutes, that's really hard to do down here on the surface. It's effortless from orbit. So that combination of it all happening at the same time, to me, that's what's exciting. And the technology is just good enough now. It's like 1487 when Bartholomew Diaz for the first time sailed around the south tip of Africa, or 92, or whatever you choose a time, 1903 when the first airplane flew. Suddenly there's a giant step forward in technology that opens up a whole new opportunity. We have to be ethical and thoughtful about how we deploy it, but I don't think we should ignore it or deny it just because we're uncertain of the future.
Thank you, Chris. Okay, so you've heard the arguments, audience. Let's hear from our audience here in the theater by applause. By applause. How many of you think that space exploration should be left to the robots?
They were waiting for the robots to applaud.
Yeah, that delayed reaction said so much.
I almost hate to ask, how many think humans should be in space?
Me too.
Okay, well, it seems like we're on our way. For those of you who voted yes, there's a Canadian Space Agency collection box in the lobby. Now, we do have a little time to take some questions from our live audience and also on Twitter. So if you have a question here in the audience, put up your hand, and we have some runners with microphones who will get to you. So while that's happening, I do have a question here that came to us on Facebook. Guy asked, to the panel, and I guess this doesn't apply to Chris, would any of you turn down the opportunity to personally go into space?
No.
Can I plead the fifth? No. I mean, I would love to be in space.
Yeah.
Yeah.
But if you ask me if would I like to live on Mars, the answer is no.
Yeah, exactly. If I'm going up and can look at stuff and come home, yes. If I have to be on that first landing mission to Mars and start growing potatoes in my leavings, no. I'm gonna leave that one to Matt
If it's just
Damon.
go to space and sing a song with Chris, I'm there.
I'd like to go also.
Good. Would you go to Mars?
Yes. Well, I didn't say this in my summary, but my opinion is we won't go to Mars with people with the engines that exist right now. It's prohibitively slow, and we can't protect ourselves, and the risks aggregate. So I think we will settle Earth orbit, and we'll settle the moon, and we'll start working on the moon and maybe on asteroids, but I don't think we're going to Mars until we invent, like go from propellers to jets, or whatever that equivalent will be, from rockets to something else. So yes, I would go to Mars, but I don't think anybody's going to Mars until we can get there a lot faster than we do right now.
Okay. So, question from the audience on this side. Oh, over here. One of you.
Oh, yes. Hello, folks. On behalf of everyone here, thank you for your inspiration. Chris, Amy, Bob, Renee, Marianne.
Thank you.
Thank you. You're real-life superheroes. And I'm looking for the next Quirks and Quarks book to be a collection of Bob's comedy. I think it's outstanding.
They won't let me do that.
A quick question about space tourism. CBC broke the story 2 days ago about NASA allowing people on the International Space Station a paltry $35,000 a
Million.
night. You probably heard.
Oh, per hour or something.
Oh, per hour, yes.
Yeah,
And
yeah.
I think plus the small fee of $58 million for the rocket to get there.
Yeah.
So I'm just curious, with Chris, obviously your intense training to become an astronaut, to be part of that. What do the other astronauts feel when you have one percenters are going to go up there taking selfies when you have trained astronauts up there? How do you
We've
feel?
already done it many times.
Yeah.
There have been lots of tourists already fly to the International Space Station. They flew with the Russians, including a Canadian, Guy La Liberté, did that. The real question is, it's sort of like if you fly in Air Canada, you're not the pilot, you're not the crew, but you can buy a ticket and go, and you sit in the back, and they give you that little safety briefing, that shows how to do up your seatbelt and where the emergency exits are. That briefing for the space station takes about 9 months. And so long as people are willing to take the 9 months and learn where the exits are and how to do up their seatbelt, then I think that's fine. I mean, essentially, we're all sort of tourists up there. Just some of us have a lot more qualifications. And so I'm not against the idea. I think it's natural. If we can get the safety level good enough and the cost low enough, it's just natural that more people should have access to it. So I think it's fine. But it's still prohibitively expensive for almost everybody. So, I think it's a good stepping stone. And the Russians broke the ice on it decades ago when they allowed tourists up.
And there are plans for a new space station that will exclusively be a hotel. I think is Bigelow is going to build that.
Yeah, there are plans. We'll see if it gets built or not. But yeah, there are people talking about it.
Talking about it already. First guest, Bob. Thank you. You buy me the ticket, I'm there. Yes, okay.
Yes.
Oh,
Hello?
Okay. Next question.
Yes, hi. This is a question for the panel. I'd like you to enter a time capsule, and you arrive at 2030. President AOC has set a mandate. How do you see spaceflight in that coming decade?
2030?
2030 to 2040.
Okay.
President AOC has set a mandate like President Kennedy did.
That's not that far away.
It's not.
Well, yeah, actually, and maybe this was also a bit of my answer to the last question. I'm really curious about accessible access to space and kind of applying principles of equity to space. And when we talk about new space, who's going to be able to go? More people will be able to go. It's less stringent for health conditions, things like that. I'm curious if we open up tourists to the International Space Station, do we frame that as like a B Corp model where if there's a tourist going and paying a ticket that they are also required to do some kind of social good while they're up there? So I think there could be some interesting models that are merging in entrepreneurship land and new tech that could be applied in the setting, and I think she would explore those options.
I think a lot of people want to have the so-called Kennedy moment, you know, and have that. There's always this like, we're going to go to Mars, and then it doesn't happen. So what I would love to see a clever president, female president maybe, doing in that time frame would be to actually set up, like, call for a mandate in space exploration that can't be wiped out by the next administration, because this is like the biggest frustration is you start something, you lay the groundwork, it's not done enough by the time that administration is done, because in the US it's 8 years. So then everyone sweeps it out, and then they want to build their own thing and have their own legacy, but space doesn't happen overnight. So we need somebody to actually lay the foundation and say, like, we're going to build a waypoint, and then we're going to do this, and we're going to build it up enough while I'm in office so you can't take it apart and then claim that I ruined everything because you did. We need that long-term planning in space. Everything's so hard and so long-term. Let's get that going.
And the International Space Station is a great example. The only reason it survived was because it had intergovernmental agreements and commitments. Every single partner tried to back out at some point, but then they checked the rules and realized, oh, we signed documents, we have to stay in this, including Canada. And that's okay, because, as you say, everyone goes through political cycles and financial cycles. The only way to try and get one of those things to outlast one political term is to, as a government, agree with another government that this is going to happen. And that's what we need to do as we step further and further away from the Earth.
And I think one of the things, in order to make sure that our governments have this vision of cooperation and longevity, we also must realize that as taxpayers, you have a voice, right? Some of the funding that goes to, you made a joke about the Canadian Space Agency, that's coming from tax from the public. And so if we think we can talk about our vision for space and for cooperation, then I think we can drive the conversation more rather than assuming someone else is going to do it.
And directly answer, I think we will have retired the International Space Station in the late 20s, maybe 1930, or 2030. And I think we will have people living on the moon on a temporary basis, sort of like cycling in and out of Antarctica, setting up towards a full-time permanent settlement of the moon. That's where I think we'll be by in the 2030s.
Perhaps the tool that will get us to the moon under one administration is a golf tournament. And we have,
The Shepherd Classic.
We have it at Moon Alargo. And
your drive and go so far.
Yeah. Endless sand trap.
Yeah.
Okay, question over here.
No one can hear you yell 4.
Good evening. Thank you so much for giving me the chance to ask questions, actually, because I had to skip school to be here. So, I'm a grade 6 student, and I'm a huge fan of space, and most of my projects for school revolve around this topic. There are journals that have been published in regards to physical health of astronauts. However, I haven't really come across details regards to the psychological effects on astronauts while they're in space and after they land. This goes for both male and female astronauts, given how small the space station is, which is about the size of the stadium, and you're constantly floating.
Great question. Thank you for that.
Thank
Psychological impacts of space.
Yeah, thank you so much. No one has ever skipped school for me, and I feel like a rock star. As an educator, I want to make sure everyone knows you should go to school, but occasionally skip for me. No. So actually, there are some projects that are looking at some of this. So funded by NASA, there was the High Seas mission, SEAS, that has had many incantations and is testing at places like Hawaii and the Atacama Desert. If you build a biodome and put people inside for some period of time, how do they survive? How do they grow food? And they even simulated disasters like lack of communication or issues like that. I think, of course, we need more of those because, yes, I think space would get quite lonely. A lot of my colleagues work at the South Pole, and sometimes they need to stay over the winter, and they reduce the base down to very, very few people, 50, 60 people. And when they get reintroduced into society, when the new teams come, they really struggle initially because they feel isolated and alone. And so I think we need to be careful about planning for futures in space.
And for the space agencies, we didn't used to take that seriously. When we went to the moon in the 60s, we didn't just think about it at all. It was just a race, and we did our best. And it was very psychologically hard on the people that went to the moon. No one has ever treated them the same since they got back, and there was no real decent psychological preparation. And the early space stations, the early Soviet space stations, there were times where they had fist fights up there, where they stopped talking to the Earth for a week at a time. They did not have good psychological planning, training, or real-time support. And we've learned from our previous mistakes. We work really hard on that now. We have a full psychological support team on Earth, behavioral health. They work with us for all the years that we're in the office. They work with our families back on Earth. They work daily. I talked to a Canadian psychiatrist or psychologist once a week the whole time I was on the space station. Drove me nuts. And dad joke. And no, we take it very seriously. I think it's a really important part, but we're also going to learn from it. You know, what type of person do you want to send to the South Pole or to the moon? What type of psychological attributes? How can you make people more resilient so that they're better suited to go do that? And then how can you support them real time the further away they get, both in distance and time? You know, it's a really important area of study, and we're working on it.
Just want to kind of add one thing to that, just because you mentioned the Apollo program. The way of making them not go crazy on the moon and have that moment of like, oh my God, I'm standing on the moon, because even thinking about that just like makes me anxious. They just talked all the time. Matter was like how they tried. They're like, oh, you guys want sports scores? Oh, you guys want some music? They just constantly like nattered at them, which also sounds really annoying. So I honestly wonder like how we're gonna stop Mars from becoming like Survivor Mars. And I'm so glad that people are taking it seriously. But I do want to, I don't know if I can ask Chris the question while we're here. Did you have that moment of like, oh my God, I'm floating in space in a little like when you're on a spacewalk?
Oh, like 10 times a day. The whole, oh yeah.
Did
it's
they
the
let you
coolest thing
have
ever.
that moment of quiet to feel that?
I made sure I stole those moments. I didn't want to come back from space and not have noticed where I was. And I used to be a fighter pilot and a test pilot. I tried to savor the rareness of even those experiences all the time. I knew there was going to be a point in my life where that particular activity would go away, and spaceflight was so much richer than that. And so yeah, I tried to miss nothing. I didn't want to come home from space and say, I didn't do much, but I was well rested. I didn't think that was, so I slept as little as possible. I tried to just absorb, and then I did my absolute best to try and share it, including being on Quirks and Quarks. Thanks for inviting me today.
You were. You were. Marianne, what about the psychological aspects of it?
Well, I was just going to add, if you're interested in the research and looking for studies, obviously there's some based on astronauts, but that number is limited. There are a lot of great analog or kind of simulation studies that Renée referred to, like high seas. But there's also analog environments on Earth, like Antarctica. So the meteorite hunting program I was a part of, astronauts participate in that program as well, NASA astronauts. And many of them say it's like the next best thing to being on station in terms of the conditions and the team dynamics. And so those groups are studied. I volunteer every time I did remote field work to be part of a psychological study. So there's data out there, and there are kind of these similar analog missions on Earth that are in addition to the astronaut studies.
Okay. Now we're getting close on time, so I'm going to ask the panelists to give us shorter answers, if you can, right to the point. And I'm going to take one here on Facebook. Katie asks, what is the number one impact you think space travel has for people on Earth? Number one impact.
Space travel has people on Earth?
Yes.
I think it depends.
Inspiration.
I was going to say either inspiration or trickle-down technologies that you don't know make your life better every single day.
Yep.
Inspiration.
Yeah, and classic right here. It depends who you are. I don't tell you what's relevant to your life. If you need solar panels and more efficient ones, guess what? Space is important to you. Or if you're like me and I'm inspired because I want to go, inspiration is important to me. But yeah, it depends.
It's great. I asked for short answers. I get one word. That's great.
See, we listen.
GPS. Is that 3 answers?
Ooh.
Matthew on Facebook asks, how do you feel about the prospect of humans mining the surface of our moon, Mars, etc., and visibly changing the face of those bodies, either visible from up close or from afar?
I don't like that idea. The company that I work with, we made our initial precept is we won't do anything to change the appearance of the moon. You know, even like if you put a shiny object on the moon, that would, you know, so that you could reflect the sunlight and then the moon would now shine at you. I mean, you've now imposed your will on 7.5 billion unwilling viewers. So no, I think we need to reach agreement on what is sacrosanct and what is not, and I think that's important.
I'd be gutted if someone went up and mined the moon and it looked different.
Or wrote a corporate logo,
Yeah.
big swoosh on it
Oh,
or
God.
something up there. That'd be
Don't
bad.
even. Don't put the idea in anyone's head.
Brought to you by. Okay. Okay, let's take one from our audience over here.
So I guess my question connects back to our debate of should we have humans in space? Should we have humans in space when we, A, are in the middle of the Anthropocene, and B, when our current technology is leaving enough space junk that we might become Earth-locked as it is? So what do we do about those two problems, and how do we ethically justify the race into space with those considerations?
Okay, how do we justify the race into space when we're in the middle of the Anthropocene here on Earth? Critical time here on the planet.
Yeah, I mean, I think I agree with you. I think we really need to pay attention to what we're doing to the planet. Please all recycle, and let's not use plastic bottles. In addition, you know, I think working, so all of my data comes from satellites, and some of my data comes from satellites, and some of that, those satellites have a plan when they run out of coolant, and so they can no longer take scientific data. They have to have a plan for how they're going to be eradicated or destroyed, and sometimes that means, you know, flying into Saturn or something that is going to destroy the satellite but not actually leave junk. And I think we need to come up with better regulations to make sure that we have a plan, especially if we open up space to private industry.
Yeah, we are addressing that plan. The group that regulates in the United States, that is a prerequisite to the constellations that are being launched right now. We've always had serious problems to solve on Earth. They just seem really magnified right now because we're the ones that are facing them. It seems like everybody in the past had it easy, sort of. That's a little bit of a trite thing to say, but I think it's also a natural human trait. And we tend to discount the hardship that our predecessors had because we're in a hardship of our own. We have to work hard right now. If we truly want to get this standard of living to 9 billion people, then we have to change some things significantly if we're going to make it sustainable. That's not beyond our grasp, but we just have to prioritize it and make that something that we truly want to do as a species. We're probably going to have more pain before we want to change the way we're doing it right now, but it's not unattainable. That doesn't mean we should stop doing everything else. We still need to progress. We still need to push the edges of things while we're working here with the vast majority of our effort on the middle.
Yeah.
Go ahead.
A short answer. I think there's a value in these big, audacious goals, and space exploration is one of them. And again, I said this during the debate, but we cannot undervalue the power of awe and wonder and what that does to our human soul. I think those are important elements that make us human. So in the same way that you would never say, well, maybe this is a bad comparison, but you know, we're not going to do music because it's too expensive, right? Like there are things that are important to us as humans, right? And so I kind of put the big audacious goal of space exploration and that inspiration piece in there.
Okay. If I can just throw in my 2 cents, space exploration is not that expensive. The Canadian Space Agency budget, the annual budget, works out to less than $10 per person in Canada per year. $10. That's what it costs us.
Donation
We
box.
spend more on beer than we do on space. So if we're going to pick on where do we spend our money, I think there are other areas where we could pick on where we're wasting money rather than space exploration. It doesn't need to be that expensive when you amortize it over the whole population. My little 2 bits. Okay, one more question from online here. Adam on Facebook asks, what's the best way to broaden access to space? To broaden access to space.
I think decrease the cost of launch and increase the ability to virtually be there. And by virtually meaning images, movies, music, books, actually letting people go around the space station with a little robot like they did in the Tate Museum, where you could drive a robot around the Tate Museum at night. That sort of opportunity for people to virtually experience it, I think. And I think we've done a good job of that compared to where we were just one generation ago. Everyone has a view of the world now that we did not a generation ago because of the way we've tried to share the experience. I think we need to do more of it.
But also, because a lot of space research is funded by space agencies, national space agencies, you actually can have access to data that comes from these missions. So for example, all of the data that I use, we publish and we put our data out there. So you can actually get your hands on it. And please do, because we want the public to look at the data.
Yeah, there's some really good citizen science initiatives and science communicators if you're out there putting your stuff online, engaging with people to discuss it. It makes a huge difference. I always joke, and it's not really a joke, that science communication exists because engineers and scientists don't speak English. So we need to translate for people, and that's really valuable.
Okay.
I think that helps.
All right. Before things completely break down here, just one more quick question from the audience, and then we'll wrap it up.
Hi there. As the human focus moves towards settling on Mars, do you think that landing on the moon again and setting up a colony there is an important step towards Mars, or something that isn't very necessary and we can just throw ourselves into Mars without landing on the moon?
I think it's important as a way stop. The moon is about 3 days away, and Mars is about 2 years away. And like I said earlier, the light time delay with the moon is negligible, and with Mars, it's 7 minutes one way. If you're trying to work out the technologies and how to do something, doing it on the moon first is like a training ground is not a bad idea. It's not a bad place to start, where you can actually, something goes wrong, you can get home relatively easily. Something goes wrong on Mars, I mean, we all saw The Martian, and it probably won't work out that well.
I agree. I'm full on in the camp of the moon is a stepping stone on the way to Mars, and the lessons to be learned there are important. Never mind the medical conditions. We can't go to Mars right now with issues of understanding radiation effects and space of that long duration mission. So the training grounds of Mars, or sorry, of the moon is important. I'm going to let Chris has a few points to bring up.
The recent discovery of 400 billion liters of water on the moon is really significant. We don't know for sure how accessible it is, but there's a vast quantity of water in the North and the South Pole and the shadowed craters. Also, the fact that the moon sits perfectly upright in the solar system. It's not tipped like the Earth and tipped like Mars. That means if you put a solar array at the North Pole or the South Pole, it is going to get sunlight forever. So you have unlimited, or at least uninterrupted power, and you have a very deep reserve of water. So to me, that absolutely makes it an imperative that we go to the moon next. And it's, as you say, only 3 days away. So I think that's where we're going next. It's the next lily pad out into the pond. And we've already shown we can get there, but now I think we need to show that we can stay there.
There's also a counter-argument to that, which is just build a big enough rocket, and Elon Musk is working on one, and go to Mars direct. Why go back to the moon? We've been there, done that. If we were going to become an interplanetary species, Mars is a planet, the moon's a moon.
We didn't build one ship and launch out of Europe for Australia on our first try. If we had, everybody would have died multiple times. We had to sail up and down the coast for centuries to figure out how do you navigate, how do you make the boat work, how do you do all those things. And if we could launch for Mars right now and everybody would die every time, and then we'd learn some stuff. But is it really worthwhile? And so if the cost is low enough, then you don't have to ask what the point is. But if the cost is high, you have to ask what the point is. And so I think the cost is still high enough in risk in human life that you have to be able to justify it some other way. So for me, I'm all for it. I want to go to Mars. I just don't think we're technologically able yet.
Mm-hmm. Well, that's it for today's program. Our thanks to our amazing guests, Amy Shira Teitel, Marianne Mader, Renée Hlozek, and Chris Hadfield. Quirks and Quarks is produced by Cece Wong, Sonia Biting, and Mark Crawley. Our audio team today was Austin Pomeroy and Andrea Morales. Our live streams were produced by Andrew Nguyen, Shanisha Yolich, Olsi Sorakina, and Ruby Buiza. Special thanks to the team here at the Isabel Bader Theatre at Victoria College at the University of Toronto. Our acting senior producer at Quirks and Quarks is Jim Levins. I'm Bob McDonald. Thanks to our audience here in Toronto, all of those in cyberspace. Thank you all for listening. Thank you.